fellow talked about the ether, and I do want to make sure that we dot all the I's and cross all the T's, or cross all the I's and dot all the T's, whichever one, right? And what do we say? Well, we say the ether is a bunch of particles. That's what I've told him. And he did not like that. And no aetherist likes that. In fact, all the people who vouch for the ether never figured out what the ether is. Okay? And so the question is, where does the word ether come from? You know? And so this is what the fellow said. He said, ether cannot be a bunch of particles. Okay? And this is more or less what all the etherists that have come here to debate say the same exact thing. They say, it ain't what you're saying, Bill. Okay? It ain't particles. I know it's particles. It's always been particles, but these people have another notion of what the ether is. And so you try to pull their tongue, pull their brain, whichever one, to try to find out what do they have going through their minds. What are they thinking about when someone mentions the word ether? What's going through their minds? So the fellow first says, no, it's not a bunch of particles. Okay, great. The reason why the ether cannot be made of particles is very simple. What's the stuff between the atoms, keeping a bunch of atoms together to form an object? Aha. And he answered his own question there, why the ether can't be. Yeah, the ether can't be because of that. Because, you know, you have to have something between any two particles. And if you don't have something there, how do they interact? Especially pull, you know, entanglement, gravity, any pull. Even if we concede it, you know, gluons pulling two quarks together, it's always pull. And the only force that no etherist on planet Earth ever was able to answer is the force of pull. And this is where they fail. They cannot answer the force of pull. No one can produce a pull unless they put something between two objects. Period. There's no possibility, and so they all try to pull. They all try to produce pull through push. You know, Casimir type or Lesage type mechanisms, where you remove what's between two particles and the ones on the outside push them towards each other. That's the notion of pull. But they cannot produce pull because for that you need an elongated object that somehow physically binds any two particles. And of course, since they can't see or touch anything there, they said there's nothing there, and so they're going to do it through push. Push is the only mechanism they ever were able to explain. They have never been able to explain pull. And so he says a magnetic field cannot be made of discrete particles. Absolutely. You're totally right there. And I'm on your side there. Again, you can't have gaps. Same for gravity. If you have gaps, then magic is responsible for the interaction. Absolutely. Simple as that. Totally in agreement. That's why the ether can't be, because ether is a bunch of particles. But this fellow has a different notion of what the ether is, and this is more or less, I guess, where it comes from. In the days of the Greeks, they thought the ether was air. Ether means air, is another word for air. It's just the air of the gods. And what do you think they thought of the air? Well, they thought of the air as particles. And even to this day, people think of air as particles. We call them atoms, we call them molecules. But what is air? Air is molecules. And the ether was just some other type of particles that we could not see or touch. But it was the motion of those particles, especially in a wavy motion, that they studied throughout the 19th century, thinking that a wave of light consisted of particles, of discrete particles, you know, waving up and down, oscillating. That's what they all thought. What did you think the ether was when they talked about the waves of light? They thought it was the wave of light was made of particles. You know, and they did it mathematically. They said it's a bunch of vectors, electrofield, magnetic field. That's essentially what they concluded. But what do you think they had in mind? Why do you think they? What do you think Michelson and Morley were testing? Well, they were testing to see if there were particles, gazillions of particles. And they wanted to see if the Earth was going against that ocean of particles, and if there was a difference in the speed of light, etc. Okay, so they always thought of particles. And these people say, no, it's not particles, Bill. Okay, so here we have space. Okay, very dark, very nothingness. Okay, so we call that space. And now we're going to put some ether in there. Okay, it looks like this. Okay, and that's the ether, a bunch of particles. That's what they always thought. Okay, that's the way they always pictured it. Okay, okay, so here we have the universe. Okay, and pretty static because, you know, so far away we don't really see things moving. You know, they're so far away that we really see everything kind of static out there. The firmament, as it used to be called. And here it is, the universe with particles, okay, with these ether particles. And everything is made out of these particles, not only the objects such as the galaxies and stars and so on, but also the space in between them. Everything is particles. That's the way everybody's always seen this. Nothing has changed in the last 10,000 years. Even those people who say the ether is not particles, what do you think they propose? Well, they don't even realize they're proposing particles. And in fact, it happened to this fellow. He says the following. He says, this is what he proposes. He says, I'm saying the ether is a continuous fluid. And I already told him that, you know, fluid is made of particles. You know, because that's what fluid is. It's a substance that is made, in fact, he put the definition there, a substance, right? Such as a liquid or gas that can flow. Okay, but what is he saying? It's a liquid or a gas. What is a liquid or a gas made of? Atoms. Made out of discrete particles. That's why it can flow. So if you're going to use the word fluid, you got to relate it to how the word fluid is defined. Otherwise, you got to define the word fluid in a different way. Okay, substance that easily changes its shape. Yeah, he hasn't said anything. Capable of flowing, changing, readily shifting, not rigid. So you can't say that ether is a fluid because the word fluid is a verb, not a noun. Okay, so you can't say ether is a fluid, right? Fluid means is what ether does, if anything. Okay, so you haven't told us what the ether is, you're just telling it what it does. It flows. That's all you're saying. And with that, you haven't told us anything because we still don't know what the ether is. You have to point to the ether first, static, before it moves. Then you can make it flow and fluid and whatever you want. But first, you got to point to it, in a static mode. You know, you don't point to a running lion or a galloping horse. You point to the horse and say, horse. And now I'm going to make the horse gallop, and that's going to be a galloping horse. And now you see the horse galloping. So we can understand, we can follow your train of thought. First you point to the ether, then you have the ether flow or be fluid or whatever. Yes, a fluid often refers to liquids and gases. Yeah, in fact, it does only refer to that. Okay, so are you saying the ether is a liquid or a gas made out of atoms? And if it's not made out of atom, well, you got a lot to explain. Okay, you can't just say it's a fluid. At least those are the ones we know the most. Yeah, it's the only ones we know. So you can also say that, when you ionize gas, it becomes plasma, but plasma is not an object. Plasma is moving gas. Okay, you've got something moving. It's called ionization. Okay, so something is happening. Happening is a verb. Okay, so plasma includes the object and the motion. You can't get rid of the motion from plasma. But there is absolutely, it's like, the word, the dead cat, no such thing in science, in physics. Physics, there's only a cat. Dead is what he does, and alive is what he does. But the object is called cat, only cat. No dead cat, no brown cat, no yellow cat, no jumping cat. Just cat. Yes, a fluid often refers to liquid, okay, but there is absolutely no reason why the ether can't be a fluid. Well, yeah, okay, so it's a fluid. All you told us is what the ether does. You haven't told us what it is, but you're saying it can't be, meaning what it is. So you don't understand. You don't understand that fluid is a verb, not a noun. Fluid is a category of things that flow. Okay, it could be gases, could be liquids. So when you say ether is some kind of fluid, you just put it under a category of things that flow. And still you haven't told us what the ether is. You haven't pointed to the ether. That's why we need a picture. If you absolutely insist, I'll draw you a blob of ether. Okay, and then you see, like, you can point to water, you can point to oil, you can point to molasses, right? You can point to all these fluids, right? All these liquids, right? But at least I can point and say, okay, I know what molasses is. It looks like that. Oil is that. Water is that. Okay. The fact that they're fluid, it doesn't mean that you've shown what it is yet. I mean, are you saying that ether is molasses? Why not? I mean, so far you haven't pointed to it, so I'll point for you. I'll say, you're saying that ether is molasses. And if you say no, you haven't. You gotta. The onus is on you to tell me what it is in the alternative if it's not molasses. Okay, so that's the way it works in science. You have to tell the crowd. Don't expect the crowd to tell you what the ether is, because I'm going to tell you what the ether is. A bunch of particles. That's what it is. What it's always been. You don't like it, then you got to put something there for us to see and say, look, this is the ether. If you think ether is an object, and he says it's a blob. Okay. Okay. But here is the some of the problems with what he's saying. He's saying it's a continuous fluid. Continuous in physics means made of a single piece. Okay, that's what continuous means. And it's the opposite of what the Greeks thought of continuous. Aristotle very clearly states that continuous means that you can break it into pieces. It's made of parts. So it's the opposite of what continuous is in physics, which is made of a single piece, not made of parts. That's what continuous means. So the ether, this fellow says, is made of a single piece, and it's fluid. So I don't know what he's talking about. Is he talking about rubber, or what is it, you know? How can it be made of a single piece and be fluid? And yet this is how we look at the single thread under the rope model. It's continuous and it's fluid. In fact, the single thread contains all the properties of solids, gases, and liquids. And in fact, that's why we have solids, gases, and liquids, because the single thread contains all these properties within it. Okay? It has that ability. But fluid is a noun plus a verb. Okay? You can't have something called fluid. There's no physical object, standalone object called fluid. Okay? Fluid is a noun that does something, verb. So fluid is not a thing, a substance or an object. Fluid is what a thing does. Okay? It's a verb. It's just like plasma. Plasma is a noun plus a verb. Okay? Plasma does not, you can't point to plasma. And people say, oh, I pointed to plasma ball and a plasma in it. No, what you're pointing to is a verb. Something is happening inside the plasma ball. If it's standing still, it's called gas, not plasma. For it to be plasma, it's got to be moving. It's got to be ionizing. That's what plasma is, ionized gas. Without that ionized, it's not plasma. It's called gas. Okay, and I don't know if you understood that. Wind, again, another. Wind is not a thing. Not a physical object. Okay, wind already involves or invokes or embodies motion. It's moving air. Okay, field, same thing. Any kind of field you want. You want gravitational field or magnetic field, no problem. Electric field. It's the difference between forest and many trees. Okay. Okay, forest and many trees are the same, but you're treating field as if it were one tree, or if the forest were a single object, and that's not the case. Field is like a forest, and it means many values. That's what it is. And likewise, the ether means many corpuscles. That's what the ether always has meant. But apparently this fellow thinks it's a blob. Okay, so what do? Well, since he hasn't done it, I'm going to do it for him. Okay, we're going to make ether a blob, just like he said. We're going to try to follow what he described. Okay, that's all I can do. Okay, so here it is. I showed this last time. We have the astronaut, and he releases a blob of some kind of liquid, some kind of fluid in space. You can call it water if you want, even though it's kind of greenish, but we'll call it water. No problem. Okay, so we got that. And here we have the blob up front so we can see it much better. Okay, and there you see it. Okay, and what's the issue? The issue is with this, now you have to explain light and gravity with that blob. Okay, and so here's what you got to explain. Here's light. Okay, you got to explain waves of light inside the ether, if that's what you think light is. Otherwise, you got to explain light in some kind of way. And all I can do is put what people always have thought, that light is the vibration of the ether, and that's what I'm showing there. If you don't agree with that, no problem. You have to tell us what you think light is in your blob or under your blob or outside your blob or whatever. Aside from the fact you got to tell us what the black stuff is that gives shape to your blob, because if you're going to talk about a blob, there's something outside of it, and you have to identify that blob. In other words, that black stuff. In other words, what you got to tell us is if the blob has shape, and hopefully it does. If you're going to talk about a blob, then you got to tell us what it's what is within it. In other words, the black stuff is that space. Is the blob contained within space? And what is space then? You know, because a lot of people identify the ether with space. In other words, a lot of people think that space and ether are synonyms. There is no such thing as ether and space. They're both the same thing. Other people think that ether is within space. Okay, and that's fine, but then you got to tell us what space is. Okay, you can't just say it's within space because we don't know what space is yet in your theory, in your hypothesis, in your way of thinking. Okay, okay, so here let's put the blob. Let's freeze it. Okay, there you have it, frozen blob. Okay, in fact, we'll go a step further and we'll put it on white so that we can see it really well. Okay. And again, those who proposed a blob have to tell us what the white stuff is, in this case, right? No problem, but you got to identify every object in our field of view. You got to tell us what the white stuff is if the blob is ether. Okay, so far so good. I hope you can follow along. I'm going to try to be as slowly as possible so that everybody can follow along, okay? Okay, so we got to explain gravity well, you have to explain light, that's one issue, but now we have to explain gravity. And I'm going to put a scenario, okay? Here we have a little spoon that falls to the floor, okay? If you don't believe spoons fall to the floor, go to your home, go to your kitchen, take a spoon, let go of it, and you'll find out under normal conditions, it'll fall to the floor. We call that process, whatever is doing all that whole thing, we call that whole phenomenon, we call it gravity. Okay? Okay, so now what we're going to do, we're going to freeze the spoon in midair. Okay? So far so good. It's going to fall down, but we just froze one frame so that we can explain the following. We're going to go in there now, and we're going to use the blob. Okay? Is the blob pushing on the spoon? That's one of the things, one of the possibilities. Okay? If you think the blob is pushing on the spoon, you got to tell us why and how it does it. You know, what the cause is. You know, why does the blob go downwards instead of upwards, for example? You know, if this is the way you visualize it, okay? Again, I'm not putting words in anybody's mouth. I'm just saying this is one of the scenarios you got to explain if you think ether is a blob, okay? Here's another one, okay? This time it's below because the blob is going to pull on the spoon. You got to explain to the crowd how it is that the that the blob pulls on the spoon. Why does it pull? Why is it going downwards? Why doesn't it go upward? Why doesn't it push from the bottom upwards, for example? You know, and all these things you gotta really analyze that to death. Okay, if that's what you think, the ether is a little blob that's pulling or pushing. Okay. Now the important thing here that I want you to focus on, because I'm sure he's going to reject these two scenarios, right? And a lot of the etherists will as well. They're saying, Bill, you're treating the little blob. That's not our ether. Our ether is the entire universe. In other words, the ether covers all of space, the whole universe, or whatever, right? Okay. The reason I put these two scenarios down and showed them here, illustrated them, is because I don't want them to say that there's a portion of the ether that pushes or pulls the spoon down. In other words, we'll call this the little blob. Okay, we'll call it the little blob. The little blob either pushes or pulls on the spoon upwards or downwards. Okay, we'll call that the little blob. Now let's go with the big blob, which is what these people usually think of when they say ether. Okay, here's the big blob. Okay, now, here we have the earth. We have the spoon falling to earth, and you can see the blob. I have expanded it greatly, and we will assume that the blob that covers the entire earth, it stretches all the way to the ends of, all the way to hell. Okay, so now we have the little spoon falling, and again, if ether is the entire ocean, the entire blob that covers the entire universe, you have to explain how this blob moves the spoon downwards in one region of the universe. In this case, space. In this case, your home, your floor, your house, right? So you got to explain how the whole ocean does this. And just in case, here's the one coming from below as well. Remember, someone you're in the North Pole, and the other guy's in the South Pole, and so your spoon is falling towards the center of the Earth. This spoon is falling towards the center of the Earth, so it's going in the opposite direction as yours, and you got to explain how your blob does this. And again, we're asking you to explain how the entire ocean does this, okay? You cannot select a little piece of the ocean and say, look, my little ether here does this. No, you either talk about the ocean or you talk about water. You either talk about the forest or you talk about one tree. You either talk about children or you talk about child, or you talk about, people and you talk about man. You can't use the ether in both ways. You can't say the ether is the entire ocean and the ether also in this little region of the ether does this. Okay, I hope you understood the issue. The issue is you cannot use the ether as both forest and tree, okay, which is what these people usually try to do. They say, look, the ether is the entire ocean. It's this blob that fills all of space. Great. So ether is the entire ocean. Then don't tell me the ether over here pushed, here we have a spoon, little spoon, and we're going to let go of it. And I say, how did that happen? You say, the ether did it. Well, the ether is the entire ocean. How did the entire ocean of the entire universe, filling all of space-time, all the way to the ends of the mind, right? How did it do that? Okay, and again, if it pushes it down here, how did it also push the spoon on the other side of the planet in the opposite direction? Okay, so you got to explain those two things, right? Okay, and here, let me give you another scenario similar to that. Here's a little fish, and we have that little fish in the ocean. And here you can see the blob is covering the entire Earth, so the Earth is inside the ether, inside the blob, right? And we have a little fish within one of the oceans, Pacific Ocean in this case, within the Earth, okay? So now we're going to look at the little fish inside the ocean. Here he is, okay? And he's falling towards the center of the Earth for some reason. Something is pulling the fish down. Maybe it's a whirlpool. Maybe something is sucking it downwards. The fish can't help. He falls, okay? So he can't avoid it. Here we see him a little more, blown up a little bit so that we can see the fish going down. Okay, so the question is, the fish is going down. You cannot say the ocean did it, okay? In the best of cases, you can say the local water somehow, there was a current or something that pushed him down. But what is irrational is to say the ocean pushed the fish downwards, okay? Because you would have to explain that process, how the whole ocean, the whole Pacific Ocean pushed that little fishy down towards the center. We don't usually talk like that. We don't say that, the ocean pushed the fish down. You can say that a current did, or maybe there was some whirlpool that pulled on the fish. You can do that, but you got to talk about whirlpool and not about ocean. And the same way with ether. You cannot talk about the ether doing gravity if you're going to say that the ether is the entire ocean. Okay, because otherwise, if you're going to use the ether and the little blob, then you got to explain how the little blob pushes and how the little blob pulls. Now you got to go to that scenario. Then, I did not put words in your mouth. I'm just saying that if you're going to treat the blob as a portion of the blob, then we forget about the big blob, and you got to look at the little blob and how that little blob, pushes the spoon down or pulls it from below. Okay, so you either talk about the ether as the whole thing, the whole ocean, or you use some other word to refer to the little blob or the big or pushing or pulling. In other words, that's the homework. If you want to take it and want to resolve it. Those are the issues, those are the questions. I hope you understood them all. Otherwise, look at the video later on and figure it out what it was all about. Okay, let's move on to another issue that this same fellow, I think, raised, and it's got to do with this word ray. You know, the only rays I know are these fish that are in the sea, that kind of ray, okay? But here it is. I think it's a fish. I don't even know if that's the case. Okay, so where'd it go? Let me get this up here. Okay, so a fellow says, Young has never seen light. Talking about Young, the, what was his name? Thomas Young, who did the slit experiment. Okay, so he says he never saw light waves. Of course not. If he would have seen them, it'd be a cinch. If anybody would see waves, it'd be great. In fact, if you can see a wave, you can see a concept such as wave, boy, you've got good eyes. You got better eyes than God. It has never been more than an assumption. Exactly. And that's what it always is. It's called an assumption in science, in physics. So that's what a wave is. It's an assumption, not something to see or touch. It's an assumption. Good. Same for J.J. Thomson. He never saw electron particles. Okay? And he said the cathode ray tube experiment was freaking ray. Was a freaking ray? What do you mean a ray? What is a ray? You know, from one end of the tube to the other. And what do you think that ray was made of? Oh, I don't know. Tell us. Why didn't you tell us? And yeah, J.J. Thomson did not see a ray because, like, good old Ray there, he was blind. He couldn't see it. That's why he couldn't see the ray. Okay? So we have to look up this definition of the word ray to find out what this poor fellow is talking about. Okay? And so here you have it. A ray is an idealized geometrical model of light or other electromagnetic radiation. So it's an idealized geometric object. That's what it is. So there is no such thing as a ray. It's a straight line. That's all it is. And that's what it's always been used as. So you can't use the word ray because it's, first of all, it's a mathematical or geometrical object. It's not even an object. What it is an arrow that represents motion. You start at A and you move to infinity. That's all a ray is. So you can't use the word ray and say that light or electricity is a ray. Okay, so here we have the version from the rope model. Okay, and here it is. What is light? That is on top of Ray Charles there. Well, light, every one of those rays, as you call them, we say it's a rope. Okay, in fact, it's not a single rope. You got gazillions of ropes there per ray. Okay, because the rope is such a thin object that we can't see an atom, much less a rope, which is much thinner than the radius of any atom. Much, much thinner. So you're talking about something that we can't see or touch for that matter. Just like we can't see the air, we can't see a rope. But that's what those light rays, beams are. You know, what we're staring at is the vibrations of the rope going from atom to atom. Okay, so what you're seeing here is atom to atom, and the ropes are striking one atom and being relayed to another atom all through the air. And that's why we can see all those, that light. Okay, what you're seeing is really the vibration of atoms. And electricity, well, electricity is at the bottom. Okay, you talked about a cathode ray tube, CRT. And that beam, that ray as you called it, well, that's a bunch of atoms. Actually, molecules, I like to use the atoms because they're easier to explain, but it's easier to understand it with atoms because you just put hydrogen atoms there and you merge them and you say, okay, let's assume all these hydrogen atoms are merged. Okay, and then what you have is counterclockwise and clockwise rotation of that whole string of merged electron shells. And that's what we say is electricity. Okay, so we do have an explanation for the CRT, the electricity or current running from one plate to another, and of a light, which is what you see on the top. And now the ball is in your court. You tell us what a ray is and what you think it's made of, And if you're going to put your blob in there, ether blob, no problem. Explain to us how the blob does light, how the blob does gravity. And again, like I explained a minute ago, you are supposed to put the scenario where you have this ocean and explain it with the ocean. And if you cannot explain with the ocean, if you're going to go to the actual falling of the spoon, for example, then you have to talk about the little blob, which is the first two scenarios I showed, where one pushes, the other one pulls, and explain that. So you decide which one you want to go with. Okay, ball's in your court.